In this video, we're going to look at percentiles and quartiles, and we're going to look at this example data set here. That we might imagine these numbers are a sample of apartment rents. That we went out and we looked at a bunch of one-bedroom apartments in a small town, and we collected these monthly rent figures for them. And as we have been doing in the previous video and this one, and will continue to do, we want to look at some ways to summarize all these numbers into just a few numbers so that we can understand the properties or the characteristics of this data even more. Now, in the last data set, we looked at the mean, median, and the mode. So let me go ahead and tell you for this data set what those numbers are, and we'll interpret them again. And then we're going to move on and we're going to talk about how to calculate and interpret percentiles and quartiles. Now to do that, let's go into Excel here real quickly, and let me show you how you would find the mean, median, and mode in Excel. And then we're going to come back here and focus on percentiles and quartiles. Okay, here we are in Excel with our data in a block like this, and if you wanted to find the average, it's very easy, and there are a few ways to do this, but I just use equals average, and you can highlight all those numbers and then hit enter. So $490.80 would be the average rent for all these apartments. Now we can find the median, similarly equals median, open parentheses, select the data, hit enter. $475 is the median. And the mode equals mode, open parentheses, select the data, and hit enter. The mode is 450. Now remember, in my previous video I showed you that you need to be careful, or I mentioned that you need to be careful. In Excel, if it tells you the mode is 450, it might not really be the mode. It may just be the case that there are several numbers that occur most frequently. So here we see 1, 2, 3, 4, 5, 6, 7 apartments had a price of $450. And so if there were another rent, say $475, that also occurred the same number of times, Excel would not alert us to that. It would just list one of those modes, but in this case I did check, and that is the only mode. So let me label these here. So the average is $490.80. 475 tells us that half of these apartments, the ones down here and also over to here, half of these apartments are over $475, and the other half, these up top and these are under $475. So that's the median, and the mode is $450. Now let's go back to our list here so we can look at the percentiles real quickly and talk about what they are. Well, let me go ahead and introduce it here. A percentile is a number that tells you that a certain percentage of your numbers, a certain percentage of your data are less than that percentage. And we have one percentile here. The median is also what we call the 50th percentile. And it's the 50th percentile because 475 is a number where 50% of the data are less than it. So the median is the same thing as a 50th percentile. But what about other percentiles? In general, a percentile, you can think about this either going backwards or forwards. A percentile, you could look at a number like 425 here, 425, and ask yourself, what percent of apartments cost less than that? Well, the answer for 425 would be basically 0% of the data are less than 425. So we could say that 425 is the 0 percentile, or 0th percentile. Right? Let's look at the highest number here. And let me choose a color that's a little easier to see, 615. What percent of the apartments are less than 615? Well, all of them basically. Now some of you might be asking yourself here, what do you mean that all of them are less than 425 when there's one that's equal to 425? I agree with you. Same thing with 615. It's not really true that 100% are less than 615. When you talk about percentiles, normally we talk a little bit loosely about whether things are less than or equal to. And so I'm not going to get hung up on that distinction, although mathematically I understand you should be careful. When you're talking about percentiles, what you're trying to do is find approximately what percent are less than, or approximately what percent are greater than. So this precision difference between greater than or greater than or equal to, for example, is not a big deal. Other teachers might have a different opinion about that, but that's my opinion. It's not all that important to be so exacting. So 615 we could say is the 100th percentile, because 100% percentile, because 100% of apartments are less than or equal to $615. As we talked about before, the median was 475. And the median were the 50th percentile. 50% of the data are less than or equal to. Most people, when they talk about percentiles, use those more or less interchangeably. Less than or equal to $475. Most people don't get hung up on that distinction in this particular case. What about other percentiles? So we have the 50th percentile, the 0, and the 100th. What if we wanted to calculate any percentile? What number would be the 20th, or the 35th, or the 98th percentile? How do we find those? Well, what we need is a method that we can always stick to that will find any percentile. So that's what I'm going to share with you right now. Let me warn you, though, there are a few methods, and Excel is one tool that uses a kind of a wacky different method that nobody else uses, or very few other people use. I'm going to teach you the most standard, most common one that I've seen. And it has a few steps. So let's just go ahead and start going through these steps so that we can use it. Because while I'm writing down these steps, it can be confusing until you actually use it a couple of times. Here are the steps to find any percentile. And for any, let's use the term P percentile, or the Pth percentile, where P could be 0, 100, 50, or 30. So P is any percentile. How do you find that? Well, the first step, step 1, we're going to calculate I. I is an index number. So the index number I is equal to, take this P, whether it's 10 or 50 or 90 or whatever, and divide it by 100, and multiply that times n. How many numbers are there in your list? So let's do in parallel an example here on the right hand side. Let's suppose we wanted to find the 20th percentile. Okay, so here's what we would do. We would calculate 20 over 100 times n. In this list I have 70 apartments, so times 70 equals what? Well, that's going to equal 14. Now 14 is not the percentile, but it's a start at giving you an idea about where in the list it is. That tells us it's somewhere near the 14th item in the list, going from smallest to largest. Now the second step says, look and see if that I that you just calculated is an integer or not. So if it's an integer, then what the rule says is your percentile, the number that marks that percentile, is going to be the average of I and the next one in the list, I plus 1. That's all that says, I plus 1. Let me erase that because my handwriting is bad. Try to make that a little easier to see. the average of the I and the I plus first in the list. Now, what do I mean by that? Well, over here we got I as 14. That's an integer. So what that says is go to the 14th number in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right here, 445. The 20th percentile will be the average of the 14th and the 15th number in the list. 445 and 445, they're the same number, so we don't have to average them. Technically, we would average them, and we would get that the 20th percentile is $445. All right, easy enough. Now, but there's another case. What if this was not an integer that we got whenever we did this? What do you do then? Well, let's find another percentile where this is not going to be an integer anymore. What if your boss told you, go out and find the 43rd percentile for apartment rents? That is, we're looking for a number, an apartment rent, where 43%, or approximately, these are always approximately 40%, 43% of the apartments will be less than that number, and the other 57% will cost more than this number. How do we do that? Well, we do the same step. We take the P divided by 100, 43 divided by 100 times 70. Do this along with me and see what you get. And what you get is 30.1. 30.1. Aha, not an integer. So the second part of this rule here says, what if it's not an integer? The rule says we're not going to average anything. What we're going to do is we're going to take that I and we're going to bump it up to the next number. So take I and bump it. Some instructions say round, but it's not rounding, because if we rounded 30.1, we would round it to 30. We're not rounding, we're bumping it to the next integer. So bump it up to the next integer, which in this case would be 31. So we take our index number, I equals 31, and then we just use that number in the list as our percentile. So find that number in the list. So when it is an integer, you're going to be averaging two numbers. When it's not, you bump it to the next integer and find that one in the list. So I equals 31, the 43rd percentile. See, this is 1 to 10. This next row is 11 to 20. You have to put them in order first. That's also key. And this is 21 to 30, 31, right there. That is going to be the 43rd percentile. And these two before we found, let me just label these as we get them, the 20th percentile was 445. So, to recap, no apartment, 0% or less than 425, 20% approximately or less than $445, about 43% or less than $465, about 50% or less than $475, and we could keep going and find all kinds of percentiles as we go along. Once we have this little method, there's no limit to the percentiles that we can do. Let's just do one more percentile. Well, actually, let's not do one more. Let's do two more percentiles because that's going to wrap up this lesson anyway. There are a few specific percentiles that you hear people talk about a lot, and so this is where we get into quartiles. Sometimes people will talk about quartiles, deciles, quintiles. What in the world does all that mean? Well, remember, if we lay our data end to end in a long row, and we want to chop it in half, that one number that chops the numbers in half is the 50th percentile, or the median. Or the median, same thing. That means we're chopping the numbers where half the numbers are less than that number and half are greater than that number. And what we found up here is that our median is 475. So 475 splits the apartments into two equal-sized groups. Now, we could also, if we want to split up it a little more into other equal-sized groups, what if we split it into 4 groups? Well, we'd have to take the bottom half and split that equally. We'd have to take the top half and we'd split that equally too. And we end up with 1, 2, 3, 4 equal-sized groups here. Now, how are we going to do that? Well, when you split them into 4 equal-sized groups, this number right here is going to turn out to be the 25th percentile. And the one up top is going to be the 75th percentile. So there's 1/4 of the data below here. There are 2/4 below the 50th percentile. There are 3/4 below the 75th percentile. And so that gives us a different name for the median and the 25th and 75th percentiles. Some people call this the first quartile. First quartile, or Q1, because it's that first number that splits the data into 4 quarters, or 4 equal parts. At the median, sometimes people will call the second quartile, or Q2, and the 75th is Q3, the third quartile. So it only takes 3 numbers to split the data into 4 equal quarters. Now, when you find the quartiles, you do it exactly the same way, using that same percentile rule. So let's find these 2 quartiles, the 25th percentile and the 75th percentile, and then we'll be done with this lesson. But you could just as easily picture doing quintiles. A quintile divides the data into 5 equal groups, 20, 40, 60, 80, and 100%. Or deciles would chop the data into 10 groups. But let's find the 2 quartiles here using our same method. Let me just erase over here. And again, as with all things statistics, if you want to understand it, do it along with us here. So, the first quartile is the 25th percentile. So we put this 25 into our formula, 25 over 100 times 70. See what you get. We get 17.5 as our index number. Then we go to our second part of our percentile rule. Is it an integer or not? Well, 17.5 is not a whole number. It's got the 0.5 there. So the rule says bump that up to 18 and find the 18th number in the list. So let's go back to our list. This is the first 10, 11, 12, 13, 14, 15, 16, 17, 18. The 18th number in the list is 445, which just happens to be the same thing as the 20th percentile. But that's okay. That's why you have to say these things we're finding are approximations. So the 18th one in the list is $445. That is the 25th percentile. Approximately 25% of the data are less than $445. Now let's go find the 75th percentile. Same kind of procedure, 75 over 100 times 70 equals, I get 52.5. Is it an integer? No. Since it's not an integer, bump that up to the next number in the list. Our index number is 53. Now be careful that you don't say that 53 is the 75th percentile. Always make sure you go back to the list and find that item in the list. That's a common mistake I see people make. So 1 to 10, 11 to 20, 21 to 30, 31 to 40. This is 41 to 50. And we want the 53rd. So this is 51, 52, 53. That's the 75th percentile. So the 75th percentile is going to be $525 right there. Now, while we're here, let me just discuss two additional things. I know this video is getting long, but there are two other important things that you see people do with quartiles, and we might as well talk about them while we're here. The first idea is the interquartile range. Now, there are two common ways. Let me erase these here. Two common ways people talk about how spread out data are. And we'll learn some more in the next couple of lectures. So when you measure how spread out data is, the most common way to measure spread is just the range of the data. Now when we say range, what we want is one number to describe the range. And what we do is we just take the highest number minus the lowest number, in this case 615 minus 425, and the range is $190. It just tells us how wide this group of data is. Maximum minus the minimum. Another way to measure spread is what we call the interquartile range. Interquartile range. Inter means between, quartile, range. So you can already probably guess what this means. Inter means between the quartiles. What's the range? So what we do is we look at, well, if the first quartile is 445 and the third quartile is 525, what's the distance between those? We just subtract Q3 minus Q1 and see how big that is. So 525 minus 445 equals $80. That would be the interquartile range. What's the deal? Why would we calculate such a thing? Well, the range tells us how spread out all the data are. The interquartile range tells you how spread out the middle half. What do you mean the middle half? The upper half is easy to picture. The bottom half, easy to picture. The middle half. What's the middle half? Well, the middle half is all the numbers. Let me kind of color them orange here. It's all the numbers between the first quartile and the third quartile. So here's what I mean by the middle half. Now, you're not going to be able to see them, but I'll erase this after we get done. Think about the middle class apartments. Not the extreme ones in the upper quartile, and not the cheaper ones in the lower quartile, but these middle ones, how spread out are they? The middle half. Now that's an odd idea the first time you hear it, I know, but that's the idea of the interquartile range. How spread out is 525 from 445? Well, only $80 separates those. Why would you ever want to do that? Well, the big reason is, in a couple of videos ago, we talked about this idea of whether a measure is robust. And here we're going to see it again. Robust means we're asking the question, robust versus sensitive, we'll say. Robust versus sensitive. Sensitive means that something you're measuring changes very easily when you have an outlier, a very high or a very low number. The range is very sensitive because what if we replaced one of these numbers, say the 425 here, with a very cheap apartment in your grandmother's basement for $100? What's that going to do to the range? Well, it's going to crank it up from being 190 to 615 minus 100, which will be 515. And so that range is going to be very affected by just having one weird number in the data set, one very high or very low outlier. So the range is very sensitive, but the interquartile range is very robust on the other hand. Now why? How do we know? Well, let's go back to the same example. What would happen if we replaced this 425 here with 100? So we just cross that out and we have 100. what's going to happen to the interquartile range? Well, the 25th percentile will still be 445. The 75th percentile will still be 525. The interquartile range will still be 80. The interquartile range is not affected at all by having one weird high number or one weird low number that somehow gets into the data set. Just think about income. On one day, you go ask mostly normal kinds of people that you meet every day about their income, but then for a different study, you just happen to knock on Bill Gates's door. You're going to have one big outlier there, and your range is going to go crazy, but your interquartile range would not change at all due to having that one big number in there. So it's robust. And this is an advantage of numbers sometimes. So that's one idea. The last idea I just wanted to share with you is a graph. And the graph I'm going to share with you right now is called a box and whisker plot. Box and whisker plot. And I'm going to share with you a very simple version of a box and whisker plot. This is a plot that you can do very quickly to get a visual representation of what's going on with your data. There are more complicated ways to do box and whisker plots. There are about, dozens of different ways you can do it. I'm going to show you the simple box and whisker plot, and you make it just by using the numbers we've already talked about. And those numbers are going to be the minimum, and the minimum in our data set was 425 before we crossed it out. So let's clean this up a little bit. We need the minimum, we need the first quartile. So we need the first quartile, we need the median, we need the third quartile, and we need the maximum. Those are the 5 numbers you need to make a simple box plot. So how do you do that? Well, let's just go down here. What you have to do is draw an x-axis and label it. Before you start putting your numbers on there, label it. And the point is, sometimes I see people just write down the numbers in any old locations, and then you're not doing a plot of any kind. So we need to make sure this plot goes from 400 at a minimum up to, our maximum was a little above 600. So here's 700, say at a maximum. And then we want to divide this and label these accurately. Now you could do this with a piece of graph paper. I'm just going to kind of wing it here, but try to make it as accurate as I can. Halfway in between 400 and 700 would be the average of those two, 550. So I'm just trying to picture here, what if I divided this into 3s? 450, 500, 550, 600, 650, 700. So we can get a picture of what's going on. So let's label our points. Our minimum, here's how you make a basic box and whisker plot. The minimum value was 425. Let's put a dot there. The first quartile was 445. Let's put a dot there just below 450. The median was 475. Yeah. So that's going to be halfway between 450 and 500. The third quartile was 525, halfway between 500 and 550, and then the maximum was 625 over here. Now, we've got those 5 dots on here. Here's what a box and whisker plot looks like. The box, you draw around the first and the third quartiles. You draw a line in the middle to show where the median is, and then you draw little whiskers, lines, down to the minimum and up to the maximum. And sometimes people will put a little bar on the end there. Now this is the basic idea. There are more complicated ways where people identify outliers in using different methods, and they'll identify outliers as a star over here. We're not going to go through that difficulty because there are so many ways you could do it. This is just the basic box and whisker plot. But if you ever see a couple of stars out here, that'll mean that they had some outliers that they omitted from the rest of the data set. for you and marked them specifically. But a box and whisker plot is neat because it's very easy to draw, very quick, and it shows you these numbers, the minimum, the maximum, and therefore you can see the range. It's in between those two numbers. How big is the range? You also, since you have the first quartile and the third quartile, you can compare that distance between the two. That shows you the interquartile range, right? IQR, interquartile range. The middle 50% is right there. Another thing you can see, and we'll talk about this when we start looking at some histograms soon, is you can tell that this data is kind of stretched out on the right-hand side. It's kind of compact on the left, but this last between third quartile and the maximum, it's very stretched out to the right. And that's an indication that this data, when it's stretched out to the right, we call that skewed. And it's skewed, we say it's skewed in the direction that it is stretched. And here, since this is so stretched to the right, we'd say it is skewed to the right. So there are a few things that you can learn about data that are very cool, basically from this very simple diagram. So I'll wrap it up here. If you have any questions, please leave me a comment in the comment and question section below.